Okay, welcome to Sarah sir. Just check your voice. You are not audible, sir. Just unmute yourself.
Good afternoon, sir.
Good afternoon. Okay, just we will wait for the participant to join.
Yes, yes.
I will start our session on 2:37.
Yes.
Yes, ma'am. Yes, your voice is clear.
Yes, ma'am.
Sudhir sir, you are there? Sudhir Gaikwad sir? Sujit Patil sir, are you there?
Yes, sir, I'm here.
Mamunka sir?
Bamankar sir is here, sir. He is just checking your connections and all.
Okay. Nice.
देखिए सर आता तरी दिसतीये का मी? मी दिसत कशी नाही मला आश्चर्य वाटतं सर. हो. कोण आलंय? जरा केसर मी का दिसत नाही बघा जरा. ते म्हणतात मी दिसत नाहीये. पाठीमागून जाऊ मोबाईल घेऊन जाऊ माझा जागेवर बसा बघू 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 थांबा थांबा दिसते ना हां सर या दरवाजा लावा हो नका लिव्ह करू अटेंडन्स आहे आमची तिथं पण अटेंडन्स आहे आमची
The participants will wait for another 5 to 6 minutes so that we can start our session. Just hold on.
सर माझी वही दिसते का बघा कॅमेऱ्यात माझी वही दिसते का बघा चष्म्याने मी व्यवस्थित वाटते का बिना चष्म्याने व्यवस्थित वाटते बघा निखिल सर हे बघा मी बंद करते हो करू का 3, tick tick 2, tick tick 1. 2 minutes to go, Bavankar sir.
Manuel, just share the academic flyer there, or either Francis.
Yes, sir.
Share the academic flyer on the screen.
So slide share करायला सांगितली त्यांनी. Flyer. Courtesy sir, are you there? हो courtesy sir मला सांगा की. Good afternoon, everyone. I am Professor Amita Mane on behalf of Sri Santatma Institute of Engineering and Technology, Department of Mechanical and Department of Mechatronics. I welcome you all to our 5-day FDP on automation and sustainability practices, manufacturing, logistics, and modern living spaces. This program is organized by Department of Mechanical and Mechatronics. Yesterday's day one of the FDP session was on realities of modern living spaces by automation, and the speaker was Mr. Vijay Andulkar sir. The day one of FDP was full of knowledge, and the session was very informative for all. Sir has explained about realities of modern living spaces by automation. He explained what is integration and automation system challenges. He discussed about automation energy management. He also explained how AI is helping in automation. Overall session was excellent. Today is day 2 of FDP. Today's topic is sustainability and automation in Industry 4.0, best practices for the future, and the speaker is Dr. Amit Kumar Shelar sir. Now I request our respected HOD, Professor Bharadraj Bhosle sir, to give introduction about today's esteemed guest. Thank you.
Thank you, ma'am. Am I audible? Sunil Gaikwad sir, Sunil Patil sir, Dr. Amit Kumar Shelar sir.
Yes, sir.
Shelar sir, are you there?
Yes, sir. Yes, sir. Yes, sir.
Start our session by introducing. So, welcome you. So, good afternoon, everyone. So, it's my great honor to introduce yourself and our today's for the audience. Our today's distinguished speaker, Dr. Amit Kumar Shelar sir, who is Assistant Professor in the Automobile Engineering Department at SVTM Institute of Technology, Malegaon, Baramati. With more than 15 years of experience in teaching, research, and academic leadership. Dr. Shelar holds a PhD in mechanical engineering and has strong experience in areas such as sheet metal forming, forging optimization, CAD/CAM application, and advanced manufacturing processes. He has published many research papers in reputed international journals, conferences, and also served as a reviewer for Scopus and SCA in these journals. In addition to academics, he has worked with leading industries including Daisy Vehicles Private Limited, and during his research work and research journey in Bharat Forge Limited and Kalyani Technology Limited for strengthening his industry exposure. He has guided several student projects, achieved outstanding academic results, and actively participated in curriculum development, training, industrial activities, etc. His interests include sustainable manufacturing, industrial automation, and smart engineering education. So today he will guide us on the topic Sustainability and Automation in Industry 4.0, Best Practices for the Future, which will surely inspire us to connect modern industry practices with academic growth. Let us warmly welcome to our today's speaker, Dr. Amit Kumar Shelar sir. Welcome, sir. Without taking much time, I request Dr. Amit Kumar Shelar sir to take a charge and of this session and share his valuable knowledge with our participants. Please, sir.
Thank you for the warm welcome, Bhosle sir and team. And good afternoon, everyone. So let us begin with our day 2 presentation. So whether my screen is visible?
Yes, sir.
Yes, sir, it is visible.
So let us begin with our presentation. So all today we are here for 1 week FDP on sustainable manufacturing and industrial automation. Today is day 2 and I'm going to cover topic sustainability and automation in industry 4.0, best practices for the future. So basically in this presentation, I'm going to cover introduction, sustainability in mechanical engineering, automation and industry 4.0, best practices for the future. In this part, I'm going to cover various case studies related to sustainable manufacturing as well as industrial automation, and finally the conclusion. So part 1, sustainability in mechanical engineering. So what is, let us start with basic and go in depth as the slide progresses. So what is sustainable manufacturing? Basically, it refers to the use of methods which minimizes the negative impact of manufacturing on the environment, society, economy, while maintaining the quality of the product produced, even improving them. So basically, it is a branch of sustainability which deals with economical, environmental, and social objectives of manufacturing activities. Now, the question is why sustainable manufacturing is critical. Basically, climate change mitigation. When we talk of automotive technology, recently laser cutting technology with 30% of energy, means in cutting whatever energy is going, that is reduced with the help of laser cutting by around 30%. Okay. And if you ask me one more thing, one more example is there. In textile industries, it is shifted from coal powered boiler to solar powered heating system. So basically now the renewable energy, textile industries are shifted to renewable source of energy. And second point, resource scarcity challenges. If we see in case of automotive parts, recently AI technology is introduced. How it is introduced? Basically, it is used to judge the predictive maintenance. Means suppose any part, if we talk of a spindle or the CNC, in the CNC machine, if spindle bearing is used, so if spindle is used, so due to predictive maintenance, in the earlier phase only, if chatter is going to happen, in the earlier phase only, it is we came to know that system may go in the breakdown phase. So earlier detection is possible due to predictive maintenance, which is judged by the AI technology, and the regulatory compliance, as well as market demand for eco-friendly solutions. So these are the very important 3 pillars of sustainable manufacturing, that is environmental, economic, and social. Okay, so in case of environmental, resources and energy conservation, waste reduction, pollution control, it is the important points. Okay, so if we talk of economic, so we are looking for cost efficiency, long-term viability, products, market competitiveness project, and innovation in process of manufacturing. And thirdly, the most important pillar is social. Basically, we are always worried about our employee health and safety, fair labor practices, community engagement, supply chain transparency. If we talk of employee health and safety, so if we are shifting to renewable energy sources and which are not affecting, or there are fewer emissions, so that is our one of the biggest achievement as far the whatever the regulatory compliances are implemented by the government. So this triple bottom line framework, it is important, that is, as it prioritizes sustainability and can simultaneously protect the environmental, meet customer needs, and enhance profitability. So evolution of sustainable manufacturing. So you can see there are three different types of manufacturing. That is traditional manufacturing, lean manufacturing, green manufacturing. So what is the difference between these three processes and how evolution takes place or took place? So first is traditional manufacturing. In case of traditional manufacturing, example you can see there a car factory making 1,000 identical sedans. Basically, in the huge batches, there used to be a production, and so because of which there was huge piles of parts, means inventory was too much and finished cars were too much, so leading to potential obsolescence and waste if demand shift. Means what basically happens if suppose there is a shift in market demand or there is any changes in regulatory compliance. You can see there is a change in emission norms. So whatever the parts which are manufactured or whatever the cars which are manufactured, that might go waste. Okay, so that was the huge setback in case of traditional manufacturing. So now second type is lean manufacturing. I have given the example of Toyota. What Toyota is doing, Toyota is making cars according to whatever order is placed. So basically by doing this, inventory is reduced to large extent, and there is it creates a single piece flow to quickly spot defects, and it customizes orders more efficiently. Okay, so and the next type is green manufacturing. That is what actually happens if we talk of green manufacturing. It basically in this parameter or in this type of manufacturing processes, the company they are shifting to renewable energy, like installing solar panels on its factory roofs, using smart LEDs for energy saving, designing products for easy recycling, circular economy, and water-based paints instead of toxic solvent. So what I want to say is, by implementing green entrepreneurship initiatives such as a recycling program, renewable energy adoption, waste reduction, and energy efficiency can significantly improve the company's environmental footprint and align it with its sustainable objectives. So normally earlier we used to talk about 3R, 4R. Now in innovation elements we considered 5R. That is remanufacture. You can see in the figure, remanufacture, redesign, recover, recycle, reuse, and reduce. Okay, so in this way, manufacturing has been shifted from traditional to green manufacturing. So I have compared the few important points here. The parameters are, say, primary focus. In case of traditional manufacturing, primary focus was on maximizing output, whereas in sustainable manufacturing, balancing economic growth with environmental protection. Okay. And in case of core method, if you ask, there is linear model in case of traditional manufacturing, which prioritizes economic goals, often ignoring pollution and resource depletion. In case of sustainable manufacturing, there is circular economy, that is closed loop system, life cycle assessment, designing for durability and recyclability. Waste management. In case of waste management, traditional manufacturing viewed as unavoidable byproduct, whereas in case of sustainable manufacturing, it actively minimizes reuse or recycled, treated as valuable resource. Okay, in case of energy lines, it relies on fossil fuels, increasing carbon footprint which affect the environment. Whereas in case of sustainable manufacturing, it employs renewable source of energy, which reduces the energy consumption as well as it doesn't affect the environment. That is very important point. And last example is aluminum can production. In case of traditional manufacturing, mine bauxite, refined aluminum forms can, and it disposal was a major issue. But in case of sustainable manufacturing, recycled aluminum were used, so there was not a disposable issue, as it was designed for easy recycling. So there was closed loop. I can say there is circular economy in this case in sustainable manufacturing. Okay. So just now we have covered the overview of sustainable manufacturing. Now we are going to see Industry 4.0 overview of Industry 4.0 mechanical engineers. Basically, what is Industry 4.0? It connects physical world with digital world. Slowly, gradually, and progressively, we will see the few case studies after the overview, which will aware us how this industrial revolution takes place and what is the current scenario, what actually is happening in the current you can say current decade. So industrial automation fundamentals and application. So definition of Industry 4.0, I'm going to repeat a few times as situation demands. What is industrial automation? Basically, it refers to the use of control systems, sensors, robotics, and software to operate machines and processes with minimal human intervention. Okay, so you can see in the figure, Industry 1.0, basically it was introduced in 1784, which includes only mechanization, steam power, and weaving looms. Okay, in the year 1784. Progressively, Industry 2.0, which includes mass production, assembly line, electrical energy, which was introduced in 1870. And Industry 3.0, it was introduced in 1969, which was related to automation, computer, and electronics. Later on, means in the current decade, means whatever we are currently looking for is Industry 4.0. Basically, it has introduced cyber physical system, IoT, networks, digital twinning, and many more things which we are going to see in coming slides. Okay, now why it matters? Basically, due to industrial automation, there is abundant increase in productivity with very less defects, human errors, and less variation in dimension, or you can say negligible variation. Also, it has enhanced safety and process reliability as complicated process or high temperature process. Earlier, where human beings were doing or laborers were doing that, but due to automation, there is many growth in such cases. Also, it supports sustainability by reducing waste and energy consumption. So, fewer case studies which we are going to see later on, it will cover all these things. So, introduction to 4.0. Basically, in industrial revolution, it refers to the major changes and transition in manufacturing and industrial process with new technologies. Okay. Now, Industry 4.0 integrates smart technologies into manufacturing, such as IoT-enabled machine. If you see the example, smartwatch. Basically, smartwatch, it can determine our body temperature. And similar body signal can be given to the hospital, and appointment can be taken if we approve it. So such type of devices are there in market currently, which are very helpful for us as well as for the society. So it directly contributes to the development of the society and well-being of the human beings. Okay, so CNC machine equipped with sensors and 5G networks. So basically, what actually happens in automation is suppose there are two companies which are working on or their products are same. If there is breakdown in one company, it can virtually communicate with other company and send the signal to the second company, and they will balance the production. So such kind of technology is introduced in Industrial 4.0. And AI-based optimization. What is basically the important thing is AI-based process optimization. This technology has implemented or has introduced many very interesting facts in, and it is very beneficial to the industry. How I will say? If we say again, take example of CNC machine, and it is continuously working. So what AI-based technology will do? It will observe whatever data is collected, and it will find the abnormal pattern, due to which what actually happens, it will detect that machine or spindle is going to fail. It will give signal, and likewise maintenance can be done. So predictive maintenance can be done through AI-based techniques. Next is digital twins. It is one of the super platform which is introduced in the current scenario. We are going to discuss in further slides. Next is robotics and automation, additive manufacturing, big data analytics, and cloud-based systems. So basically, industrial automation, Industry 4.0, it covers all these smart technologies. Okay. So welcome to the fourth industrial revolution. Basically, Industry 4.0, it is a convergence of physical and digital system transforming manufacturing through intelligent, interconnected technologies. It matters because sustainability and automation are reshaping mechanical engineers, creating unprecedented opportunities for innovation efficiency. And very important, the objective of Industry 4.0 concepts into research. So here we are going to see what are the different types of automation. So basically, many of us are knowing these types. So I will again cover in very short. There are basic two types: hardware-based automation and software-based automation. In hardware-based automation, that is physical automation, there are three types: fixed automation, programmable automation, and flexible automation. In fixed automation, The equipment is designed and set up to produce single product type at high volume and high rate. Means there is only single product is produced in the large batches. Example is car assembly line. In programmable automation, the equipment sequence of operation can be changed by modifying the program. It is suitable for batch production of varying products. An example is CNC machine cutting different parts in batches. This I will be covering very short time, as many of us are knowing these things. Next is flexible automation, an extension of programmable automation that allows for almost continuous variation in the product, mixed without downtime for changeover. It uses highly versatile equipment. Now we are shifting to digital automation, that is software-based automation. Software automation is basically it uses specialized software to handle repetitive rule-based tasks within a system, often involving data manipulation, calculations, or reporting. Example you can find is automated script generating daily reports from the data. Okay, and next one is robotic process automation, that is RPA, using software robots to mimic human interaction with digital interfaces like clicking, typing, and navigating application to automate structured business process. Basically, a bot or robot copying data from an invoice system to a CRM, that is customer relationship management. The last one is artificial intelligence automation. Automation driven by AI and machine learning to handle complex, non-rule based and cognitive tasks that require perception, judgment, or pattern recognition. So machine learning system, example, machine learning system automatically classify customer emails. Okay, basically what actually AI is doing, it is a computer program which enables a machine to simulate human behavior like learning, planning, reasoning, knowledge sharing, problem solving, etc. Okay, so these are the different pillars of Industry 4.0. IoT, AI, advanced robotics, cloud computing, AR, VR technology, that is augmented reality, virtual reality technologies, and additive manufacturing. So now we are going to start with very interesting points. Here I am going to cover fewer case studies which are very interesting. Case study 1, sustainable CNC machining, energy optimization. So high energy consumption and long idle times in CNC machining. MSMEs lack methods for reduction. This was the Pune automotive manufacturer analyzed CNC milling. It's what actually was happening. There was long idle time for CNC machining and there was huge energy consumption for that. So optimized cutting, that is spindle, feed, speed, feed, depth. All these parameters were optimized. So naturally they reduce the energy consumption by 12 to 15%. And secondary, idle time was eliminated by rescheduling, so which reduces 8% non-productive utilization, which reduces tool wear and reduces material wastage. Okay, how it contributes to sustainable manufacturing? Basically, the running time was down, so lower carbon footprint, and tool life was improved, wastage was reduced, as well as energy consumption was reduced. There was cost saving and emissions were reduced. So it was eco-friendly process for MSMEs. Second case study. Now this is another example, and it can be suggested in many of the industries or MIDC areas nearby. So what is the case study? Scrap reduction in sheet metal fabrication using nesting software. What actually happened in this? Sheet metal fabrication industries face high scrap generation due to poor nesting and manual planning, increased material cost, and landfill waste. Okay, so a sheet metal fabrication workshop in Nashik generated more than 20% material scrap per production batch, leading to high waste disposal cost and increased material purchasing. I will discuss about nesting. What actually nesting is? Basically, the material which is not aligned properly in the shop. And due to misalignment or not proper alignment of the material or proper distribution of this at the stages, huge material was piled up at different location, and due to which there was increase in scrap. So this was the finding. So what actually happened? Scrap, when we have used nesting software, or they have used nesting software. By using nesting software, they have aligned the material properly. Means basically it is, we can say, the material of raw material as well as material at different stages. So by doing this, scrap rates dropped from 18% to 9% per production batch. And segregation of leftovers would enable 30% material recycling internally. Energy consumption per component decreased due to reduced reprocessing. And most importantly, research confirms that nesting optimization was an effective circular manufacturing practice. And how it contributed to sustainable manufacturing? Material circularity through reuse and recycling, reduce landfill waste and environmental burden, and higher resource efficiency aligning with circular economy principles. Case study 3, lean manufacturing for waste reduction in an electronics assembly line. And this was the case study conducted in Bangalore. So what they have implemented 5S value stream mapping and continuously improvement Kaizen. By doing this, what they have found that defects were reduced by 32%, decreasing material and energy waste. Basically, in this, they have tried to do the automation as far as possible. By doing that, line balancing cut worker idle time by 20%, and layout redesign lowered movement distance by 34%, reducing handling energy. So this study shows that lean practice significantly contribute to sustainable operational performance. Okay, how it contributed to sustainable manufacturing? It reduces the operational efficiency, lower environmental impact. Thus, it demonstrates how lean supports the economy and environmental pillar of sustainability. Case study 4, additive manufacturing for tooling in foundry. Okay, this was an example in Kolhapur actually. A cast iron foundry in Kolhapur required frequent replacement of wooden patterns. Means what was the case? They were frequently using wooden patterns. Wooden patterns were degraded after much use, so they were requiring again and again. Much time was spent in producing the wooden pattern. Okay, so pattern manufacturing consumed wood, had long lead times, and generated significant solid waste. Okay, so what they did, they replaced the wooden patterns with polymer patterns produced through additive manufacturing. Okay, so what were the important findings in this? Using 3D printed polymer patterns, it reduces pattern production time by 55 to 60%. Waste generated from traditional woodworking dropped by over 80%. And additive manufacture generated patterns improved dimensional accuracy, reducing defective castings. And how it contributed to sustainable manufacturing? It promotes resource efficient pattern production. It eliminates wood consumption, reduces deforestation impact, as well as improves product quality, fewer scrap castings, and lower energy consumption per usable part. Okay, so different types of polymers can be used for making the preparing the pattern, such as EPS or nylon, polyamide, so and etc. Case study 5, last case study, solar powered dairy processing unit in rural Maharashtra. What was the case? A rural dairy cooperative struggled with rising electricity bill and frequent power outages affecting milk pasteurization and cooling, as well as diesel generator used as backup increased carbon emissions. So there were many issues, and ultimately what was happening due to this electricity issues or frequent power outages, what was actually the issue? The quality of the dairy product was deteriorating. So what they have done, they have installed the solar power dairy processing, solar power in that unit. So installation of a 15 kilowatt rooftop solar photovoltaic system powered pasteurizers, chillers, and conveyors during peak hours. The plant achieved 28 to 35% reduction in grid electricity consumption. This was one of the achievements, as well as diesel generator usage dropped by 90%, lowering air pollution. Okay, so what was how it contributes to sustainable manufacturing? Basically, it significantly reduction in fossil fuel dependence, cleaner energy, reduced greenhouse gas emissions, supports rural industry sustainability, and lowers operational cost. Okay, so here I have summarized all the case studies and how it contributed for sustainable manufacturing. We will see in short quickly. So, quick revision. CNC energy optimization. So, in the first case, there was energy reduction in energy consumption as well as minimized tool waste and lowered carbon footprint through optimized machining parameters. Second, we've seen related to nesting. So, scrap reduction in sheet metal fabrication, improved material circularity, reduced scrap generation, and lowered environmental impact through efficient nesting and recycling. Third, we have seen in electronic unit, that is lean manufacturing in electronic assembly, eliminated process waste, reduced defects and resource use, and enhanced eco-friendly through lean practices. Fourth, we have seen additive manufacturing for tooling. Okay, this for pattern. Wood pattern were replaced by polymers. So reduce raw material usage, minimize scrap, and improve process accuracy, leading to lower waste and energy use. And last is solar-powered dairy processing. It has cut down the fossil fuel dependency, reduces greenhouse gas emissions, and lowered operational energy footprint via renewable energy adoption. So these were the few examples. Also, this is the last example under sustainable manufacturing. So it focuses on the assembly, assessing the properties of mycelium-based composites, which are potentially environmental friendly and sustainable materials. So you can see in the diagram. So this is a diagram of mushroom. So from that mycelium-like root-like structure is extracted, that is mycelium, and you can see the third figure, which shows that cell wall, nucleus, septum, and hypha. This is one structure which is zoomed to find the different terms inside it. And you can see the nanoproteins, glucons, chitin, cell membrane, and membrane protein cell wall. Basically, from the mushroom, forming fungi are made up of multicellular structure of hypha. You can see this. And this hypha primarily made up of chitin cell. You can see this chitin cell wall and membrane proteins. Okay, so what basically this mycelium-based composite material, these were the alternatives for non-biodegradable materials. So this was the efficient discovery. We will see the application in this slide. In a mycelium-based composite, a substrate of organic matter provides nutrients and that facilitate the growth of the mycelial network. These organic material in the substrate are available as the remains of dead matters of plants and animals, as well as their waste production. Okay, so basically they are composed of cellulose, hemicellulose, tannin, and lignin, as well as protein. So this research emphasized the significant potential of utilizing mycelium-based composite. You can see the figure. What it shows mycelium-based composite material. First one is mycelium-based sandwich composite, and second one is mycelium-based foam. So basically, in this figure, you can see that thin laminate is facings are there, and these mycelium-based sandwich composite, basically it consists of mycelium bonded particulars or fibers sandwiched between two layers. Okay, example, natural fibers, paper or bioplastic, which provides additional strength and stiffness suitable for structural applications like building materials or furniture. And if you see this figure, mycelium-based foam, they are the lightweight, porous material. You can see here. Okay, created by growing mycelium on a substrate. It is used for insulation, packaging, or acoustic panels. Okay, so now we are going to see case study related to green manufacturing excellence. So BMW Group Sustainable Production, they achieved carbon neutral production at multiple facilities through renewable energy and efficient process and circular economy principle. So the most important parameter in this was they have used recycling aluminum system in the system, as well as they have used closed loop system. Basically, in this project, there was zero waste, so there was no issue of disposal, and 100% renewable electricity was used at European plants. Okay, so due to this, there were this was one of the good example for green manufacturing, as it completely relies on 100% renewable energy source. So it pioneered the sustainable outdoor gear using recycled materials, fair trade practices, and repair programs that extend product life cycles significantly. This is one of the very important thing. In the coming days, most of the companies are going to focus on this. So emerging sustainability trends, circular economy. Basically, currently companies or industries must focus on these three parameters. Circular economy. What is circular economy? Basically, it designs products for reuse, remanufacturing, and recycling to eliminate waste and keep materials in continuous use. Second parameter is life cycle assessment. What is life cycle assessment? It is assessment of the product from the raw material to the finished product and how it behaves with the or interact with the environment. So evaluate environmental impact from raw material extraction through disposal to optimize sustainability at various stages. Okay, every stage actually. And sustainable materials, third parameter, develop and adopt bio-based plastics, recycled composites, and low carbon alternatives to traditional engineering materials. By considering all these trends, it is means there are chances that company can enhance profitability. Okay, slowly, periodically, gradually, I believe much of the industrial sector will take this into account and will do progressive evolution in this field by considering these three emerging trends. So part second, automation and industry 4.0. So as I already told, I have repeated this slide here. The pillars of industry 4.0. Once again, I will repeat. So this IoT, AI, advanced robotic, cloud computing, AR, VR technologies, and additive manufacturing are the important pillars of industry. Now we are going to see case studies related to industrial automation in the further coming slides. So industry 4.0 context. Basically, industry 4.0 integrates physical technology with the digital technology, creating smart factories. And what are the different pillars? IoT, connected machines, cyber physical system, AI and machine learning, cloud edge computing, digital twins. Basically, transforms traditional mechanical industry into real-time data-driven and autonomous system. Mechanical examples, IoT-enabled CNC machine, adjust spindle speed automatically when chatter is detected. Earlier I told you this, which increases tool life and ensure consistent quality. These examples we are going to see in the case study again. So these are the overview or different automation technologies you can see in the figure. Robotics. What robot do? Robot perform the repetitive, hazardous or high precision tasks. You can see the these figures. So these are the different applications. In manufacturing, articulated robot do the painting, welding, stacking, and many more things. In logistics and warehousing, you can see in the figure AGV, automated guiding vehicles. They are used for loading and loading of the product and delivering at various stages. Goods to person. Here you can see last figure. So in this figure, there is no human intervention. Automatically, robot and load lifter is doing everything. So basically, the robot part of robot or work of robot is increasing so much, you can say. Or if there is human interference with robot, then we can say that is collaborative robot, or we call it as co-robot. So now we can means there are many technologies, or robots are there for planting and monitoring and harvesting purpose. Also, in February 2024, there was a case that in the coming slides I'm going to tell. This surgery was done with the help of robots. In transportation also, robots or drones actually, or there are self-driving cars and delivery drones which are playing many more important roles. Now this is the figure. This surgery for GI, that is gastrointestinal treatment, was done by the robot in February 2024. This was one of the very rare situation or important thing is how the industrial revolution is happening and how the robotic automation is happening. And a second figure, you can see the Uber Eats. Basically, for the food delivery purpose, in fewer cities of US, this technology is used. Uber delivers the food. So it is called as Uber Eats. And the figures are interesting. There is financial growth, that is gross booking surge from $3.1 billion to $74.6 billion in 2024. So this was the important rise you can see in the bookings. And the important thing is, such type of technology might be used in few of the cities, but this can be used for the courier as well as for the emergency drug delivery. In case of emergency drug delivery, this can be a boon. I don't think currently anywhere it is used. Okay, so now we will discuss the industrial automation, fewer case studies, how it is actually happening in the company at company level or industry level. So this is one of the factory for Siemens liquid packaging plant. You can see the figure. So first stage is bottle entry with RFID tag. RFID is radio frequency identification tag. What actually, according to that tag, which type of liquid is to be filled can be judged. Okay. And second is smart filling and detection. In second figure, you can see the filling machine reads the bottle RFID tag, and on that, according to that information, the machine automatically detects and select the correct liquid to fill in the bottle. Okay. In third stage, it is customized spout and screw application. Spout means cap. Okay. So what actually is happening in third figure? Following the filling, the machine handles the spout and screws. Similarly to the liquid filling, RFID tag instructs the equipment which type of spout and screw can be used to that particular bottle. Okay. So, and in fourth, last stage, the bottle moves to the labeling station. So what actually happen here? Correct label is prepared according to RFID information, and that labeling is done. So this type of application is found in day-to-day applications. Basically, we can see that in the patient, there is one chip is fixed in the patient, and that chip determines what is the current health condition of the patient. That is a simple example I have given. In many more cases, that RFID tag is used in day-to-day activities. Digital Twin and Cyber Physical System, CPS-DT. This is one of the very important parameter or pillar of the industry automation 4.0. What is digital twin? Basically, it is a virtual replica of physical asset, process, or a system, while a cyber physical system, CPS, integrate computation, networking, and physical processes with the DT acting as a core component, enabling real-time monitoring, simulation analysis, and control of the physical twin through data exchange, bridging the physical and digital world for smarter, optimized operation in Industry 4.0, smart cities and beyond. With the help of examples, we will find this in detail. So DT and CPS integration for CNC. Now with this example, you will come to know how actual digital twinning and CPS is acting. Okay. So basically, look at the figure. Physical twin, PT and CPS components. Next stage is digital twin, and next is CPS feedback loop. Now what actually is happening? In this case, physical twin and CPS components, in physical twinning, the critical physical asset, high speed CNC machine center and its spindle bearing, it is observed. Means basically what happens, the physical process is happening, whatever, say machining is going on. And next is, and in next step, that is sensor and networking. Physical to cyber bridge, it includes basically when a machine is running now, so during that point of time, different data is collected. Which type of data? Vibration, temperature, and current sensors connected via industrial IoT edge computing. Okay. So next is digital twin. So what actually is happening in digital twin? The core function is it compares whatever data is collected of vibration, temperature, and current sensors, etc. It compares the data with the virtual replica of the spindle bearing and machine residing in the cloud server. What is cloud server? Basically, it is a remote server in which the data of all the parameters, say vibration, temperature, and current sensor, has been examined and has been set while in designing phase. Okay. So basically, the function of digital twin is to simulate, analyze, and predict the asset's future state based on physical model and live data. Okay. So actually, it is a virtual replica, not actual model. Means digital twin, it is a very boon to the industries or the various phases, because digital twin, it is analyzing all the parameters. If you talk of this thing, this case study, then it will analyze all the data related to vibration, temperature, and current sensors. And if they in the design phase, not after production, in the design phase, then machine is in the design phase, and it will monitor all the outcomes and it will set the levels. After that, whatever requirement is there at the end, with that requirement, it can be tested whether this machine will operate according to requirement or not. Okay, so when this machine is in actual machine means physical execution process. So what actually happens if there is any variation in vibration, temperature, and current sensor, etc., then it is reflected virtually, and the prediction is done at the earlier stage, and the machine is stopped for predictive maintenance. So what actually happened due to this? The failure which is going to happen further, that is completely avoided. There is no failure occurring, as predictive maintenance or AI-based or digital twin technology has already suggested that that machine is going to be under catastrophic failure after few hours. So this is the very important discovery of digital twin, that is prediction and diagnostic. It determines the remaining useful life earlier only. Okay, so there is it prevents catastrophic failure, minimizes downtime, and shifts operation from reactive to predictive maintenance. I hope this concept is clear. One more example is there, integration of CPS and DT, data-driven smart silicon wafer production. So this is one of the silicon wafer production unit. You can see the figure. So basically it contains big data center analysis, integration, visualization, and collection. In collection part, data is collected from production plants, robot arm, cutting machine, polishing machine, viscose machine, slashing machine, and cleaning machine. Okay, so how silicon wafer production is done? So these are the three stages or areas, you can say: material and distribution tracking. What actually is happening here? RFID tracks and reader collect the data, and data fusion technology achieves material identification. Okay, so here real-time tracking and dynamic assignment of material is done through multi-stage production process. It also tracking is there, means it also tracks the at current point of time which material is where, the location of the material can be traced. Okay, it enables intelligent material assignment and real-time monitoring, reducing manual errors and improving logistic efficiency. Okay, next is fault diagnosis and prediction, identifying and predicting equipment malfunction. Okay, so what actually happens in the earlier stage only, the malfunction of is predicted by collecting data related to vibration, temperature, and flow rate in case of wafer machine. Again, vibration data from the multi-stage wire slicing machine is processed using wavelet transform design. See, the important parameter is fault is diagnosed and predicted. It achieves predictive maintenance, automatically triggers warning to mobile terminals when vibration signal deviate from normal patterns. Okay, that's what actually happens when there is alteration in vibration signal, then it sends a signal that there is some error in the vibration. So by such kind of signals, there is earlier prediction of fault. Okay, so basically it maximizes the equipment lifespan by doing the maintenance at the earlier stage of the occurrence of failure. Okay, so in this case, what actually happened? Third area, energy efficiency and management. It allows for the evaluation of consumption trend against historical data to determine when to conduct comprehensive overhaul. So what actually happened is, again, it prevents the failures. Okay, so understanding and optimizing energy consumption pattern across all pieces of equipment to reduce operational cost and carbon footprint. So smart meters are currently there, which measures energy consumption for each piece of equipment. Also, if there is deviation in data, that can be communicated. So earlier predictive maintenance can be done to prevent the breakdown of the entire system. So related to IoT, industrial automation, Industry 4.0, few case studies I have listed here. So IoT enabled predictive maintenance in CNC machining. So basically in CNC machining, MSMEs frequently fail unexpectedly due to lack of real-time monitoring, causing downtime, quality issues, and increased maintenance cost. So the Pune-based Auto Components MSME installed IoT vibration and temperature sensors on its CNC turning center to monitor machinery. Means see, now in that CNC machine, real-time monitoring was done, means live detection, whatever things are happening. Quality issue was checked, vibration and temperature sensors were there to monitor the temperature. So there was completely entire monitoring of machine health. So by doing this, what actually happened? Also, as I suggested, I already told you that in AI-based technology, what they are doing, they are analyzing the pattern, collecting the data, analyzing pattern, and giving the feedback system. And that feedback is used to predict the maintenance, whether all the computers are running properly or not. So in this case, predictive analytics identified early spindle bearing failure, prevention, and 8-hour breakdown. Secondly, machine availability increased from 82% to 92%. Thirdly, maintenance costs reduced by 18% through condition-based servicing. And lastly, production planning accuracy improved via real-time dashboards. Okay, so how it contributed for industrial automation? It introduced smart data-driven maintenance, which includes IoT vibration temperature sensor, real-time monitoring. Also, it reduces downtime, energy waste, and resources loss. Thirdly, it built a foundation for cyber physical production systems. Okay. So these were the thing which we have discussed. You can see the figure. Basically, first is here, right to figure connection. Means there is focus on the initial data layer using a local data server. Second is here, conversion. What actually happens? It involves collecting data, raw data, and machine level data from critical components and the controller. Okay. Third, what happens cyber level? Basically, whatever the data has been collected, raw data, sensory data, and machine level data, that is monitored using to perform adaptive health assessment and create time machine record through cyber twins. Means, for example, in this case, bearing, spindles, and machine cyber twins, all the data was collected and it was monitored. Okay, to check whether the data is there within limited their tolerance limit or not. Fourth one is cognition level. In this level, the cyber level output is checked to check machine components quality and condition and perform product quality reasoning. And last one is the configuration level. What actually is done? The final level, it uses the cognitive insight to enable self-optimized machine tools based on quality and efficiency requirement and provides self-adjustable prognostics and health management with advisory suggestions for improving asset lifetime and product quality. Okay, so next case study. This is interesting case study. Digital twin for process optimization in food processing. What was actually happening? Food processing plants struggle with variability in temperature, humidity, and machine performance, leading to inconsistent quality and high energy consumption. Means example, this example is of Gujarat. A dairy plant in Gujarat developed a digital twin of its pasteurization and chilling process. Okay, so what actually happened? Real-time simulation reduced energy use by 12% in chilling cycles. Also, deviation of +1 degrees Celsius in pasteurization were eliminated. Operational decision improved due to scenario-based predictions. Lastly, integration with IoT sensors improved transparency. Okay, how it contributed for industrial automation 4.0? It enabled virtual commissioning and predictive optimization. It enhanced product quality and energy efficiency. Also, it allowed digital testing without halting production. This is another example of robotics. Robotics and automation in electronics assembly. Manual PCB assembly caused inconsistent quality. Means there were defects very high and there was lower throughput. That means manufacturing product required lower output was there. So especially for surface mount technology lines. Okay, so this was another example of Bengaluru. So what actually they have done, they have adopted collaborative robots for pick and place and folding operations. What is collaborative robots or cobots? Basically, along with robots, there are human beings which are collectively doing some kind of work and finish till the operation finishes. So due to cobots, what actually happened, the manufacturing output was increased by 40% without increasing manpower. Also, the defects which were introduced and which were in very high quantity, so that defects were reduced, and soldering defects were reduced by 65%. Worker fatigue and ergonomic risks reduced significantly. Integration with MES allowed real-time quality tracking. Also, how does it contribution for industrial automation? Achieved precision, uniform quality, and repeatability. It enabled human-robot collaboration for flexible manufacturing. Also, it improved traceability through automation connected system. These are the references. Design. I think there is noise coming. Hello.
Yes, sir, someone is interrupting. So, I'll make it.
Okay.
You can continue.
Okay. So case study 4, AGV, that is automated guided vehicles in automotive assembly. So what was actually happening? Material handling in assembly plant is often manual and inefficient, causing delay, traffic congestion on shop floors and safety issues. So an automotive OEM in Chennai introduced AGVs for transporting sub-assemblies across workstation. Means what they did, they have introduced AGVs for transportation related issues on shop floors, which were delay. So by doing this, what actually happened? Material delivery time was reduced by 30%. Wrong component delivery error dropped to nearly zero. Shop floor accidents reduced by 40%. Integration with ERP ensured automatic material request generation. Okay, so how it contributed for industrial automation 4.0? It created a smart, self-regulating material flow system, improved safety and production synchronization, and enabled just-in-time and real-time logic information. Okay, last case study, cloud-based manufacturing execution system in precision engineering. So this was one of the case study from the Chennai. An automotive OEM in Chennai introduced AGVs for transporting sub-assemblies across workstations. Okay, so by doing this, what actually happens? So real-time OE, overall equipment efficiency, visibility improved, decision making, productivity increased by 15% due to reduced idle time, conformance reports reduced due to live quality alerts. Cloud analytics enabled comparison across machines and shifts. And how it contributed for industrial automation? It enabled a data-driven connected manufacturing, improved traceability, scheduling, and process transparency, and laid groundwork for AI-driven smart factories. So automation, now we are going to discuss what are the benefits and challenges and applications of automation in manufacturing. Okay, so benefits of automation in manufacturing. By doing this, it was observed that productivity was increased. Automated system operate continuously with higher speed and precision, leading to significant increase in output and efficiency compared to manual processes. Again, there was cost reduction. Automation minimizes labor cost, reduces material waste as the materials were used efficiently, lowers energy consumption through optimized processes, leading to substantial long-term savings. Quality, as if robots and automated machinery were used to perform the task, there was consistent quality was maintained. Also, the errors related to humans were eliminated highly, and the product quality was uniform and improved. Worker safety. So there was a situation where, say, in high temperature conditions, where human interference was not desirable, or it was very difficult for human being to relocate there or to stay there in such kind of activity. Cobots were used. By delegating dangerous, repetitive, or strenuous tasks to robots, such kind of operations will become easier. Workplaces become safer. It reduces the risk of injuries and improves employees' well-being. What were the challenges in automation implementation? So there were fewer challenges in automation implementation. Basically, it is related with, or it includes high initial investment. Automation system demands substantial capital for hardware, software, and complex integration, often posing a significant barrier, especially for small enterprise. Means if we talk of higher initial investment, from digital twinning, data analytics, Internet of Things, AGVs, cobots, so all these tasks are costly. So it has incurred some capital. Company has to need to invest some capital. So there is initially high investment for introducing all these pillars of the industrial automation. Next is technical complexity. Implementing and maintaining advanced automation requires specialized engineering skills. Integrate integration with legacy systems and continuous software and hardware updates. Next is workforce transition. Basically, automation can lead to job displacement, necessitating comprehensive retraining program and strategic approach to manage labor force changes and emerging skill gaps. Here you can say that if we talk of AR and VR, that is augmented reality and virtual reality. So what actually happens? By introducing such platforms, it is easier for human being to or laborers to understand what actually simpler training module can be implemented. But the thing is, by implementing IoT or latest automation pillars, the thing is there is requirement of skilled and trained labor. So that is another initial cost which company must incur for handling the IoT related or automated related pillars. And there is again cyber security risk. Means what actually happens by introducing this new kind of technologies, there are another chances of new attack vectors, which requires robust cyber security. Means firewalls or highly secured platform is required to maintain the data at very secure level. So that is another task which company has to observe to protect their sensitive data and operational integrity from threats. Smart factories, the future of manufacturing. Factories that uses interconnected technology, that is AI, IoT, robotics for self-optimization. That factories can be considered under smart factories. What are the different characteristics of smart factories? Firstly, real-time data collection, autonomous decision making. In real-time data collection, it is one of the very important actual parameter, because when for the particular machinery, if real-time data or live data is captured and monitored, so this technology assists us to, along with AI, to enable us to predict the maintenance, that how much RUL, remaining useful life of that particular component or the particular machine is there. So real-time data collection is important. Second is autonomous decision making. This is very interesting fact that if suppose any machinery is running, CNC machines, if you take example, it is running for long, and then it is observed that there are chances, means that data collection will by observing data collection, we will come to know that there is some kind of vibration by which that spindle may fail. So what actually is happening? Automatically that CNC machine will take the decision and it will automatically turn off. So that is another benefit. It will reduce the chatter or any spot breakdown of the component. Also, in this case, also there is no human intervention needed. So this is one of the it's a very important parameter, we can say, predictive maintenance. As I've said, along with AI, many times these IoT devices, what they did, they analyze the failure of the component at the early level, failure of any part of the machine at earlier level. So what actually, it anticipates basically. So what actually happens before the failure of the machine, we will come to know that there is some abnormal behavior. If you talk of CNC related to vibration or temperature or related to any sensor, there is malfunction. So what actually we can the system can anticipate this equipment failure before they occur. Okay, so maintenance can be scheduled to minimize highly. Last one is adaptive production. So manufacturing lines can dynamically reconfigure and adjust to changing demands, product variation, and supply chain fluctuation, ensuring maximum flexibility. So this is another good example of Industry 4.0 case study, Siemens Digital Factory. So basically they manufactured the converters, drivers, and motors. And what actually was done? This facility demonstrates advanced automation, data analytics, and interconnected system drive unparalleled efficiency and productivity. Means IoT was used, data analytics was used, and interconnected, that is networking system was used. By using all these parameters together, exceptional, they have observed that there was 99.9% quality rate, which is very efficient and you can say very good quality. So rapid time to market means reduced time to market by 75% due to flexible production lines, extensive use of digital twins for rapid prototyping and validation. High automation, over 75% of the value chain is fully automated, which enable the efficient production more than 1300 distinct product variants. Digital integration, a comprehensive digital replica of the plant is continuously updated and synchronized with the physical factory, optimizing process and predicting potential use before the rise. So this showcases the transformative power of digitalizing every aspect of manufacturing from design to delivery, creating a highly adaptable and productive environment. So these are the key skills which already I told you. With industry automation, as I said, there are some advantages. What are the cons? No, there is one of the cons is, you can say, the challenges that we require high skill labor. So to collect the data analytics, means after collecting the data to interpret that large data set from sensors and machine, and to optimize performance, predict failures, and drive informed decision making in manufacturing process. So data analytics is one of the key parameters which is required. Programming and software development. So proficiency in languages like Python or C++. So again, in this also skill labor is required for developing and customizing automation software, robotic controls, and IIoT applications, that is industrial Internet of Things applications. Next is system integration. Expertise is required in connecting diverse hardware and software components, ensuring seamless communications and interoperability across complex industrial ecosystem. Next is cyber security awareness. As I told, with this new advanced technology, there are chances of developing new factors or hacking new hackers systems which can hack the system. So to secure the data, there is cyber security which is required, which must be of very high scale to ensure that our data is not leaked or we can secure the data properly. So this comes with the advanced technology, IoT and sensor technology, knowledge of deploying, managing, and utilizing IoT devices and advanced sensors for real-time data acquisition and monitoring of industrial assets. Okay, and lastly, cloud computing. Basically, there are different platforms of cloud. AWS, Azure, Gmail, and many more. Zoho is also there for scalable data storage, processing, and deploying advanced analytics and AI models for industrial applications. So these are the key skills for mechanical engineers in Industry 4.0. So when these advancements are considered and implemented, so trained engineers, trained laborers are required to operate in such kind of environment. So collaboration and interdisciplinary approaches. So cross-functionality. Basically, if interdisciplinary peoples are coming together, so it will help for holistic problem solving and innovation within the organization. Next is academy industry partnership. So as I told during my earlier slides, that nesting, that is one of the software which can easily improve the efficiency by simply by reducing the scrap wastage. So such kind of means nesting software, like many things can be implemented in many of the companies, so which can reduce the wastage. Also, we have seen the examples of that dairy processing plant, renewable source was used, and highly dependence on that power outages were limited, like a diesel generator set we have discussed. So such things can highly benefit the company, the industry, local. So in such areas, we can have collaboration with the industry people. Supplier collaboration, deep integration with key suppliers for shared data, synchronous planning, and joint process optimization ensures resilient and agile supply chains. Lastly, customer co-creation, involving customers early in the design and development process to gather continuous feedback, leading to innovation that truly meet market need and expectations. Future trends shaping Industry 4.0. So these are the few important evolving transformative technologies which redefines manufacturing processes, supply chains, and human machine interaction. These trends are crucial for maintaining a competitive edge and fostering innovation. So 5G technology. This is upcoming technology, means emerging technology, I must. Ultra fast connectivity and extremely low latency enable real-time communication across the factory floor. This facilitates immediate data transfer for AI applications, remote control of machinery, and seamless integration of IIoT devices, greatly enhancing operational responsiveness. Edge computing, by processing such data closer to its source, solely in centralized cloud, edge computing delivers real-time analytics and faster decision-making capabilities for autonomous systems. Means edge computing, why it is important? Because by comparing with digital twins, the live condition, we can predict the failure at early stages, and we can shut down, means machinery automatically gets shut down. So that is one of the important of edge computing. Basically, this we must have equipped with for this sensors as well as 5G technologies for doing such kind of things. Advanced robotics, the integration of cobots that works safely alongside humans combined with AI-driven autonomy is revolutionizing production. This advanced robot offers unprecedented flexibility, precision, as well as efficiency, adapting to complex tasks and dynamic production environment with minimal human intervention. So, sustainability and industry 4.0 synergies. So, integrating industry 4.0 technologies with sustainability goals creates powerful synergies, driving efficiency, reducing environment impact, and fostering a more responsible industrial future. Energy efficiency. Basically, energy efficiency, if we talk of energy efficiency, real-time monitoring and AI-driven optimization of production processes drastically reduce energy consumption, lowering carbon emission and operation cost. Basically, waste reduction, data analytics and smart manufacturing enables precise material usage, minimizes waste generation and facilitate recycling and remanufacturing processes. Third one is supply chain technology. So basically, blockchain and IoT products, and providing verifiable data on ethical sourcing. So when there is interaction between blockchain and IoT, that means machinery and IoT things, so what actually happening, live data is monitored, and accordingly important decisions are taken, which is one of the very important parameters. Last is life cycle optimization. Digital twins and predictive analytics extend product lifespan, optimize machine schedules, and inform eco-friendly design for easier repair, reuse, and licensing. Basically, what is Industry 4.0 synergy? It refers to the interaction and collaboration of various technologies, systems, and stakeholders in the fourth industry revolution, leading to enhanced efficiency as well as productivity and innovation. So we are coming to the end slides. Human-machine collaboration in smart factories. So basically, Industry 4.0, it reimagines the factory floor as symbiotic environment where humans and advanced machines work together, enhancing productivity, safety, and work empowerment. As I told, cobots. These are the collaborative robots. Collaborative robot means robot doing tasks with alignment of human being. So the human means in such cases, as I told, in complex environment where high temperature environment or complicated job where a human intervention due to safety reasons are minimized, can be eliminated due to help of that robots. Augmented reality, as I told, AR overlays digital information onto the real world, guiding workers through assembly, maintenance, and training. This reduces errors, speed up processes, and provides on-demand expertise, enhancing operations precision. Skill enhancement and empowerment. Digital tools and AI empower workers with real-time data, predictive insight, and advanced analysis. This upskills the workforce, making roles engaging, intellectually stimulating, and future-proofing, involving industry landscape. Last, improved safety and ergonomics. Automated system take over hazardous tasks and while ergonomics design informed by data optimized workstation. This significantly reduces physical strain and workplace accident, creating healthier and more sustainable working condition. AR is nothing but augmented reality. It is a computer generated graphics on top of actual reality. And what is VR? VR is virtual reality. It is computer generated graphics to create entire virtual world. So this is the difference between AR and VR. Basically, AR, it is one of the important tasks as it makes the training very easy. So concluding and key takeaways. As we navigate the transformative era of Industry 4.0, certain principles stand out as critical for success and sustainability. Core insight you can see, Industry 4.0 is essential this technology is no longer optional, but a competitive necessity driving operational efficiency, fostering innovation and securing market leadership. Sustainability and automation interconnected. Automation and advanced data analytics are crucial enablers for achieving ambitious sustainable goals, optimizing resource use, and minimizing environmental impact in manufacturing. Third, continuous learning is critical. Given the rapid pace of technological evolution, fostering a culture of continuous learning and upskilling is paramount for individuals and organizations to remain adaptable and relevant. Second last is collaboration drives success. Overcoming complex challenges and realizing the full potential of Industry 4.0 requires robust collaboration across discipline, industry, and academic institutions. And our role, faculty leadership. Academics shaping the future workforce, conducting cutting-edge research, and guiding the ethical deployment of new industrial technology. Leaders play a vital role in. And this is one of the summary of forging dies. In this, whatever things we have learned, I have tried to summarize it. How forging die lifespan can be increased. So these are the things: resource conservation, waste reduction, energy efficiency, economic sustainability. Okay, so I can say here, if we talk of forging dies, okay, or the material used for forging dies, if we try to observe the microstructure and the processes which are happening at high temperature conditions, if we observe that type of situations, we observe the microstructure, we can find what are the ill effects or what are the causes because of which die can fail. So by studying all these parameters, thermal treatment, heat treatment cycles, and different things, we can contribute for increasing lifespan of forging. Few of the things I have mentioned here: resource conservation. Resource can be conserved by manufacturing few dies, so less raw material is used and reduce energy for die production. Waste reduction. So by less frequent die disposal or reduce landfill waste, that is nesting I told, lower recycling demand, we can enhance the sustainability. Means this is the try made to enhance the sustainability. Energy efficiency, to avoid new die manufacturing energy, fewer forging machining operations, heat treatment cycles, overall energy savings. So by this, energy efficiency can be one of the important points which can be considered to enhance the sustainability. Last one is economic sustainability. So by lowering down the tooling cost or making fewer production interruptions, improved economic efficiency, this can enhance the sustainability. So this was all about the sustainable manufacturing and industrial automation 4.0. I hope there are many things to discuss, but I hope this short conversation, many of the things are delivered as per the expectations of the participant. So thank you from my side. Thank you for being there.
Thank you, sir. Dear participants, if you have any questions, you can unmute yourself and ask it, or you may put it in chat box also. I will raise it. Few questions are already present in chat box. Predictive maintenance, how it save cost, or which ways are there additive manufacturing contributes to economy?
Okay, so I will take one by one. First question was how predictive maintenance can be predicted. So basically what actually happens, I will tell one example. If in case of CNC machines, if suppose we are observing the continuously vibration pattern, okay, and if it is observed that there is change after number of cycles, if it is observed that there is changes in behavior or vibration pattern of the any component, say. So it is earlier predicted that there is change in vibration cycle. So by observing that, the system gets intimidated that there is change in vibration pattern, and ultimately what happens that due to that signal, it is predicted that material may fail in future, and so machine predictive maintenance, condition based maintenance is done at that point of time. And what was the second question?
Which ways additive manufacturing contributes to the economy?
Okay, this is one of the very nicest question actually related to additive manufacturing. I was about to discuss many things, but due to time limitations, I have not discussed many things. The main this I will explain with example. Actually, what happens? First of all, you must know that additive manufacturing, many complicated products are manufactured with the help of additive manufacturing. And what actually happens when additive manufacturing we are using for manufacturing the components, many complicated components. If we talk of aerospace example, so more than 200 components are manufactured with additive manufacturing. So in such cases, number of operations are reduced as layer by layer with the help of additive manufacture that complicated product is designed and developed. Okay, so first thing is what? The number of operations which were required to manufacture that product is eliminated, and rapid due to that additive manufacturing, that component is designed precisely. Okay, so as number of products are operations are reduced, then again it will reduce the manufacturing cost. Okay, so this is one of the reason due to which it is economic, I must say.
Okay, sir. Next question is how do we decide the architecture for a new project, that is PLC, SCADA, DCS, edge devices with cloud, or a hybrid model?
Few part I can explain due to related to I can we can discuss currently. And if we ask me, if any PLC, SCADA and DCS edge devices with cloud or a hybrid model, okay, basically the role of cloud, if you ask me, many replicas are created and stored in that in the form of cloud or remote software, remote applications, and much of the data, big analytic data out of that related to fewer components is stored and analyzed. Okay, so by analyzing and comparing those data, this architecture for new project. In what sense actually you want to ask? Can you elaborate that question?
Actually,
What exactly you are expecting in this?
hello, Bamankar sir.
Actually, I'm not. I didn't understand your question actually. Can you elaborate a bit?
Hello.
Yes, please elaborate question here.
Yes, sir. Means for starting the new project, we have to decide which technology. Means PLC, SCADA, DCS, or hybrid model.
For starting new technology. Come again. Pardon.
For a new project, how we can decide? Means whether we have to go for the PLC, SCADA, or edge devices, or DCS technology, or hybrid model.
But basically, which technology we can use for new project? How we can decide?
Yes, sir.
Is PLC, SCADA or DCS which to use? है ना?
Yes.
Okay. So basically, if you ask me this, as per my limited knowledge, I will tell that there are few factors on which SCADA, PLC or DCS, that architecture decision factor basically depends on the process complexity. Okay. Also, it depends on this reliability. If high reliability and redundancy is critical, then DCS must be their best choice. Okay. If you ask of scalability, if the system is expected to grow or change frequently, at that point, SCADA can be a better choice. Okay. So depending on the system size or scalability or reliability, this can be considered.
Okay, sir. Okay, sir. Thank you.
Okay, sir. Any other participants want to ask questions? They may please.
I have one question, sir.
Yeah, please go ahead.
What key skills should diploma and engineering students develop for sustainable industry 4.0 jobs?
What skill diploma in engineering students must develop for?
For sustainable industry 4.0 jobs.
If you ask me, we have discussed the various parameters. I will suggest basically to learn most importantly about the data analytics, how data is analyzed from the big system. Okay, and one of the important fact is how the integration of digital twinning and cyber physical system can be integrated to or can be such platform things or such different operational simulation software which are required for digital twin. I will tell you for simulation. There means for digital twinning, learning digital twinning, there are two types of simulation, that is operational simulation and predictive simulation. Basically, the software which are required for this is Ansys Twin Builder, Siemens NX and Plant Simulation or MATLAB. So this software might help to get high skilled job in case of industry automation 4.0.
Okay, thank you, sir.
Sir, I have also one question. How can government policies encourage sustainable automation in industries?
Government policies.
Yes, sir.
So, if you ask me, what I believe is currently, if you see, if we need to launch any industry, okay, we need to have certification from an environmental forum. Okay, so right now, if you go through the Sustainable Development Goal (SDGs), so there are many of the criteria are such that which go in hand with government policies. So basically, if emissions criteria we are certifying, okay, so that is one of the key contributing parameter. This government for government side while launching any industry. And another thing, if you ask me, so there are government. If the government is making any policy regarding recycling, actually government is working on it. We already have discussed 6R strategy: recycle, remanufacture, redesign, reuse. All these 6 pillars. So basically, this is awareness program which is implemented by government at many scale, at many levels. So basically, government is trying their bit to launch such kind of programs to and to promote the sustainable development.
Okay, sir. Thank you. Is there any questions remaining?
Participants, is there any questions? So that we can move forward to the concluding this today's day 2 session. Okay, first you can conclude this session. Thank you, Sela sir, for your insights related to the sustainability and automation in Industry 4.0. Surely it's a best practices for the future. Thank you very much.
Thank you, Sheila sir, for your valuable guidance. Now I am hand over the session to the Professor Nikhil Patil sir for the vote of thanks. Nikhil Patil sir, please.
Thank you, Gaikwad sir. Good afternoon, all. Myself, Nikhil Bhagwan Patil, Assistant Professor at SSIT Gurgaon. We are highly thankful to our esteemed speaker for today's session, Sustainability and Automation in Industry 4.0, Best Practices for the Future. Honorable Dr. Amit Kumar Sheila sir has shared his rich professional experience and in-depth insights into automation in Industry 4.0. Sir has described about expert inputs, real-time example and practical approach have added significant academic and professional value to this session. At said, I extend my sincere gratitude to all faculty members, research scholars, for their valuable presence in today's online session. Thank you all. Now today's session is over for day 2 faculty development program.
Thank you, sir. Thank you.
On 18th December 2025 at 2:30 p.m. day 3 faculty development program session will be started. On topic sustainable machining of aerospace alloys, and speaker would be Dr. Prashant Jadhav sir. All participants are requesting to give your 100% attendance for this session. Thank you all.
Thank you. Thank you. Patil sir, thank you. Tera sir.
Thank you, sir. Thank you.
To all the participants, we share the feedback link in the group so you can fill that for the day 2 feedback.